Hey guys, I'm coming to you with the electromagnetics lecture. This is my second attempt. About 10 seconds into the last one, a spider crawled off my table onto my leg, so let's try again. The getting into electromagnetics, there's a guy that you need to know his name. His name's Hans Christian Ørsted. Hans Christian Ørsted, O-E-R-S-T-E-D. He was the first person to really observe that relationship. He was a Danish physics teacher, and really one of the most important discoveries ever was done kind of accidentally, but through great observation. He had a compass sitting next to an electric wire and saw that the compass was moving because of the wire, and lo and behold, that relationship is discovered. That is where we get motors, that is where we get generators, that is where we get speakers. So many things we use every day, all the time, are based on that relationship that Ørsted discovered through critical observation in his lab. And that is basically that an electric current creates a magnetic field. An electric current creates a magnetic field, and that the vice versa is also true. That was learned later, that magnets can create an electric field. We can use a magnet to pull electrons along a wire. So really important discovery. Hans Christian Ørsted, this is in 1820. So electromagnet, let me define electromagnet for you. That is a temporary magnet made by wrapping a wire coil carrying current around an iron core. An electromagnet is a temporary magnet made by wrapping a wire coil carrying current around an iron core. So some of you have done this in labs before, in middle school or earlier in high school, where you take a wire and wrap it around a nail usually and attach it to a D battery, and you get a much stronger magnet. That's an electromagnet. So an electromagnet example, electromagnets are in speakers, converting electrical energy into mechanical energy, into sound, by attracting and repelling repeatedly. We see that pushing of waves, sound waves, out. So it attracts and then repels, attracts and then repels. And so it's pushing those waves out. So you can actually make that with just the wire, but it's much weaker. So if you have a wire attached to a battery, actually has a magnetic field, but it's very weak. If we wrap it into a coil, it's called a solenoid, but when we put that iron core through it, then it becomes an electromagnet. Two important things we need to look at here in this relationship. You have electric motors, and then you have generators, and they kind of do opposite things. So an electric motor is a device that changes electrical energy into mechanical energy. Electric motor is a device that changes electrical energy into mechanical energy. That includes a wire coil, a permanent magnet, and then a source of a current. And so basically what we're going to have is an attract, repel, attract, repel, attract, repel. And we have something called a commutator. A commutator is the thing that kind of switches the current back and forth from a DC motor. You have one of those in your car. There's something called electromagnetic induction. Electromagnetic induction is the generation of a current by changing the magnetic field. Electromagnetic induction is the generation of a current by changing the magnetic field. So that's going to lead us into generators. So you have electric motors and you have generators. A generator uses electromagnetic induction to transform mechanical energy into electrical energy. And so what's happening, if you will picture a dam, how does a dam work to generate electricity, which we use in Kentucky? So water falls over the dam, that's gravitational potential energy, and as it falls, it becomes kinetic energy. Now, how do we make electricity out of that? Well, it turns a turbine. As it falls, it turns, if you will, kind of like a mill, a turbine. And as it turns, there's a magnet that's gonna pull electrons across the coil of wire in there, and so the magnet is pulling the electrons along the wire, and that's how we generate electricity. So it falls, turns the turbine, and that turbine generates electricity through electromagnetic induction. So a generator uses electromagnetic induction to transform mechanical energy, the moving, into electricity, into electrical energy. The current in the coil changes direction each time ends of the coil move past the permanent magnet pole. So you have two magnets and every time that coil goes past, the field changes direction. A turbine is defined, let me give you a definition, I think most of you know what it is, but a turbine is defined as a large wheel that rotates when pushed by water, wind, or steam, connecting two rotating magnets. All right. Let's talk about AC/DC real quick. Most of you are familiar with the band. I don't know if you're familiar with the current types. DC is a direct current. DC current flows in only one direction. That's what makes it direct. It just goes one way. That is like batteries. Picture batteries. It goes out from one side into the other side. It's a direct current. Alternating current, or AC, reverses directions of the current in a regular pattern. That's what you get at your house. Your house uses AC current. And so that alternates back and forth. That's what you're getting from the power company who's using a turbine as a power source. All right, so a turbine in a dam, a turbine over a coal plant or nuclear plant, whatever the case may be. We have that rotation between ends of the magnets, all right, between the permanent magnets. And so that's where we get that alternating current. So direct current, just think direct current batteries, alternating current outlets in your house. Now there's some variations of that, but that is generally true. The last thing I want to talk about real fast is transformers. I'm trying to see my time there. Is transformers. In a power plant, you have really high energy electricity coming out of the power plant, and they use something called a step-up transformer, which increases the voltage as it goes across high power lines around 10,000 volts. So if you've ever been somewhere, I'm sure everyone has, where you have these high power lines and you can sometimes hear them buzzing and stuff, those have had a step-up transformer increasing the voltages that are sent long distances. And then near your house, you probably have, trying to see if there's one on the pole right there next to me. I don't see one. You have little gray boxes, kind of like round cylinder boxes that are gray or silver up on your light poles. Those are step-down transformers. And a step-down transformer decreases voltage as power leaves the high power lines and enters your home. And so why is it we don't want 10,000 volts coming into our house? Our outlets are 120 volts, except for our dryer and our sometimes other major appliances we might see in our house, or if we have like a hot tub or we plug in a camper, you might have 240 volt outlets. But almost all the outlets in your house are going to be 120 volts. And so that gray metal like cylinder that's up on the telephone poles, that is a step down transformer, decreasing the voltage to make it safe to come into your home. I think that is it for those. We're missing one really cool lab by doing NTI, where we're looking at calculations of how much electricity different appliances use in homes and how many people are living in the home and what city you live in. Looking at electricity costs really and efficiency. One quick note on that, I hope you realize that Kentucky is one of the cheapest places in the world to live as far as electricity goes. We're at 5 to 6 cents per kilowatt hour. There are places in the U.S. as high as 30 to 35 cents per kilowatt hour. Honolulu, places in California, and things like that. And so having large coal access, people who are financially conservative on those things, is helpful to your electric bill. When you look at appliances, those efficiency things, obviously, as far as saving the environment is important. But as far as it goes with cost, we live in one of the cheapest places in the world to live as far as electricity goes. So we're missing that assignment. Looking at how much it costs to run a washer, dishwasher, or refrigerator, and how it affects us. So I don't think anybody's going to come looking for me next year to go over that with them, but if you ever have a question about that, feel free to ask. It's a fun little assignment. All right, see you guys.